Now, what I want to explain you is I'll give you one more debugging tip about the memory windows. Okay, so there are lots of windows which are there to help your debugging. So similar windows you will find in Eclipse also. So you should explore that. Okay, and the way they work is similar. Now let's explore one more window, that is memory windows. Okay, so Keel actually gives you 4 memory windows. To simultaneously observe the memory locations. So let's just try memory 1 window. Alright, so it disappeared. So let me try once again. Yeah, here, this is a memory window. So memory window, as its name indicates, it is used to observe the memory contents. That's it. So you can observe the memory contents of flash, you can observe the contents of RAM, peripheral memory, etc. So now let's say I want to observe where exactly my code is stored in the microcontroller. So where our code actually stored in the microcontroller, our code is stored in the flash memory of the microcontroller, isn't it? So now let's observe those instructions or codes. Okay, so for that, what we have to do is we have to obtain the base address of our flash memory, isn't it? Right? Okay, so for this lecture I would like to refer some reference manual documents. So open your reference manual related to your microcontroller. So if you are using F446 a microcontroller, then you may have to open this reference manual. Okay, and if you are using STM32F407 or any microcontroller which comes under this family, then you may have to open up this reference manual. So now after opening these documents, I would like to give you some task. So just go and find out, so what is the base address flash memory of your MCU, and what is the base address of the RAM memory of your MCU. So we have to find out the answer for these 2 questions. So you can ask this question on any microcontroller, because every microcontroller will be having flash memory and the RAM memory, isn't it? Okay, so after that we will use that address here in the memory window to analyze the contents. Great. So now I am using the microcontroller, that is STM32F407. So here, go to the embedded flash memory. I think this you have done before. And if I go down here, okay, it will have this table here, a flash module organization, and under that you can see that the flash actually starts from this address. So just copy that address. So that is the answer for our question. What is the base address of the flash memory of our microcontroller? Great. So check with your microcontroller. So you must also get some address. So if you have any doubts, let me know. Great. And for the RAM, what I want you to do is go to the SRAM section. Any SRAM section here? So for that, you may have to go to memory and bus architecture, and under that you will find something called memory map, and here it is, embedded SRAM. So just open that. So the locations may be different in different reference manuals. Okay, you may have to search a little bit, and here it says that SRAM 1 and SRAM 2. That means this microcontroller has 2 SRAMs. Okay, SRAM 1 and SRAM 2, and it starts from the address this one. Okay, so now let's just copy this. Okay, so we got the answer for our question. So our flash starts from here and our RAM starts from here in the memory map of Cortex-M processor. Great. So now let's just copy this address and let's go to our Keel and let's paste here and just hit enter, and here it is. So these are the flash memory contents. So these data are nothing but instructions or opcodes, okay, which are generated for your application. The instructions are actually stored in the flash memory, isn't it? So these are the instructions, or you can also say like these are opcodes. Great. So now let's check what is the contents of the RAM. And when I paste RAM here, RAM address here, and if I hit enter, you can see that RAM is almost empty, isn't it? So there are some data in between. Okay, so we don't know what exactly is this. That's okay. So but if you see here, the RAM is almost empty. Okay, so that means our code is not utilizing much RAM, isn't it? Why? Because in the code there are no such variables which actually consume RAM, isn't it? Now let's examine our code. Okay, so these are the header sections. Of course they don't use any RAM. Okay, so those are processed by the pre-processing steps of the compilation. And this is a function. Where will function live? The function lives in flash memory, isn't it? Because this will be converted into instruction, right? And it has one variable that we call as local variable. So the local variables, they come into existence during runtime of the program. So this variable will be created in the stack memory. And this is a function, and here also we don't have anything which consumes RAM memory. That is not actually true. So because the stack memory is also part of RAM memory, but as I said, the stack, even though stack is part of the RAM memory, the stack won't grow or shrink when your code is not running. So the stack will either shrink or it will grow only when the code is running. So since we are not running code, we just downloaded and we are just checking that. So let me make that clear. Stack will start consuming the RAM only during runtime. Only during runtime of the application. Now again, these two functions are not consuming any RAM, and if you come here, so let's see what we are doing here. Let's just go and analyze this function to see any RAM is getting consumed. No. So because all are local variables. Great. So now let's see what exactly we are doing in LED on, and here also here you can see there is one variable, LED pin. So what is this? So let's go and check there. Yes, this is a global variable, but this is mentioned as constant data. So that means this data or this structure, whatever, I think this is a array of this type. So but it is mentioned as const. That means it's a constant data, or you can say constant data structure, which actually live in flash memory. So const data will not be put into the RAM memory, so that will be moved to the flash memory. You can even find out the address of this data structure, and you will come to know that that address belongs to flash area. So I'll give you one small assignment for you. So my question for you is just find out the address of this constant data in the flash memory. So this is a constant data of type GPIO pin, which happens to be a structure. So now let's move ahead. So that's the use of memory windows. So you can use memory windows in order to analyze the contents of your flash or RAM or peripheral regions. So here actually we are observing the RAM area, isn't it? So I can even edit here itself. So now let me write something here. So let's say I will write 0 cross 17. So that means I just wrote data or 1 byte of data into the memory location, that is this one, right? That means I just put a data, 1 byte of data into the RAM memory of my microcontroller. So that I can prove. For example, so I can write a small program to read the RAM address. So let me just write that. So let's say RAM read. So I'll just write a function called RAM read. And let me make it as a void function. And here, so let's first define the RAM address. So I'll just take a pointer. So this is, let's say, RAM pointer. So I'll just initialize this to this address. So I can do this, right? So here RAM pointer is a pointer variable of type uint32, that is unsigned int32. And I just initialize to this value. So now I will just define another variable int value, and I will just dereference this RAM pointer. Okay, so that means now the program should dereference this address, and it should put a value into this variable value, isn't it? Right? So it is simple. I'm just dereferencing the RAM pointer. This is simple C programming. Now when I come here, when my program, let's say, comes here, so what you expect, the value should be 17, isn't it? So let's check that. So let's compile. So let's go out of the debugging mode and now just call this function from, let's say, here. So you should keep this outside. Fine. So let's do that. So now let's compile this code, and there is one error. So what's the error? A value of type int cannot be used to initialize an entity of type uint32. So what my compiler basically saying is a value of type int. So it is saying that this is a value of type int. So that means my compiler is assuming that, because if you don't define explicitly, compiler will assume that this is a value of int. So now I am assigning a value of int to initialize an entity of type unsigned 32t star, isn't it? So there is a mismatch. So it doesn't like that. So how do you solve this? Let's say I typecast this value into uint32_t. So will it solve the problem? So I don't think so, because it will now issue an error. A value of type uint32 cannot be initialized to. So that means it is saying, hey, you are taking a value and you are putting into a pointer. I don't allow that. So it's saying like that. So let's compile this, and again you meet with the error here. A value of uint32t cannot be initialized. So what is the solution? So this is a pointer type, and this has to be pointer type. So you have to typecast it like a pointer type. So we are now saying, compiler, this is a pointer type, and this is the address which is of type uint32t star. That means it's a pointer. This is not a value now. This is not a value now. This is a pointer. So how? Because we are saying that explicitly by using this typecasting. Now let's compile. It compiled successfully. Now let's download this code first, and now let's debug. All right, so now I came into debug mode, and so now what I do is I'll just go to my memory window, and I'll just write something here, okay, 17 or something. Great. So now what we'll do is we'll put a breakpoint here in this function RAM read, and we'll just hit enter. So here you cannot able to observe the value. It should show actually. So let's go to watch window and just try to drag and drop this variable into. It is saying it is out of scope, not in scope. So I don't know why did it say not in scope, even though the value indeed in scope, right? So because that's true, the scope of the variable is actually limited to this function, right? Because it's a local variable. So the moment I move out of this function, its scope will be vanished, right? So but since I'm still in this function, the key is saying the not in scope. I'm not very sure what it's saying. Not to worry. What we'll do is we will make it as a global variable for time being to observe the value. So I'll just write int value here instead of that. So I will just initialize it to 0 and I will just remove this. Great. Now let's keep one breakpoint here and here. So let's build it. Let's go to the debug mode. Code is downloaded, and now you can see the value, that is this value is showing the value as 000. Okay, and now it's in global scale. Now key won't compile that, it is out of scope. This is a global variable, right? Great. So now let's come to this point. Hit run. So now go to your memory window and just write a data. I'll just write 17 here. So now come here, stop here, remove this breakpoint, and now hit run and go to your watch window. And yes, you can see here the value is indeed having the value 0 cross 00000017. So that means this operation actually read 4 bytes starting from here, 00000017. Alright, so now the next question for you. The contents of the value is 0 cross 00000017, but the RAM is showing that this address is having 17. So don't you think the value must be instead of that, it must be 0 cross 17 000000, right? The value must be something like this, right? So but why the value is reversed here? So you have to tell this answer to me through the course question and discussion board. Okay, just post your answer. Great.